Next, we move on to feature engineering. So dffe is equal to df.copy. Was basically what this does. It creates a new data frame called dffe as like a deep copy of like the original data frame. Next, we move on to binary features is equal to brackets main road, guest room, basement, hot water, heating, air conditioning, and pre-area brackets. Basically, what this does, it creates like a list containing the names of like all the binary category features in the data sets, and these are like the features that have like only two possible variables, whether they do or don't, so yes or no. Then we move on to for feature in binary feature. DFFE is equals to feature DFFE feature dot map yes is equal to 1 and no is equal to 0. Basically, what this line of code does is basically loops through like each of the feature and the binary features list, and for each of the feature it replaces the yes with 1 and no with 0 using like panda's map function. This ensures like machine learning compatibility, as majority of the machine learning algorithms only work with like numerical data. Then afterwards we do df.fe.head. Basically it shows us the first 5 rows of the modified data frame. So yeah. Next, we move on to handle order features, furnishing status. So furnishing order is equal to brackets unfurnished is equal to 0, semi-furnished is equal to 1, and furnished is equal to 2. Basically what this does, line of code does, it creates a dictionary that maps each of the furnishing status to like a numerical value based on like the completeness of like the furnishing, and this basically transforms like categorical values into like a numerical scale, which is like which the model can like process. Next, we move on to dffe brackets furnishing ordeal is equal to dffe furnishing status dot map furnishing order. Basically it uses the pandas map function to basically replace each of the category with its own corresponding numerical value, and basically creates a new column called the furnishing ordeal in the data frame. Next, we move on to furnishing dummies is equal to pd.getDummies brackets dffe is equal to brackets furnishing status comma prefix is equal to furnishing. Well, basically what this does is basically uses like the pandas get dummies function to create like a binary column. The three columns being basically like furnished is furnished, furnished unfurnished, furnished semi-furnished, and furnished furnished. Then data frame is equal to pd.concat parentheses brackets dffe furnished dummies and comma access is equal to 1. Basically this adds like the 3 new dummy columns to the existing data frame as shown over here, and then we do df brackets furnishing status ordeal, furnishing unfurnished, furnishing semi-furnished, and furnishing furnished dot head. Basically it shows us like the first 5 rows of the selected columns to basically verify the encoding, and displays like the original category, the ordeal encoding, and like the one hot encoding side by side. So yeah. Next, we move on to interaction terms. So df brackets area per bedroom is equal to dffe brackets area divided by dffe brackets bedrooms. Basically, what this creates is like a new feature by dividing like the total area by the total number of bedrooms in the house to find like the average bedrooms in square feet slash meters. Then we move on to dffe is equal to total rooms is equal to dffe bedrooms plus dffe bathrooms. Basically, it basically adds up all the total numbers of like the bedrooms and bathrooms to represents the total room count. Basically, this simplifies the model by basically combining like related like features into like one meaningful like metric over here. Then we move on to dffe premium property is equal to brackets dffe brackets air conditioning is equal to 1 parentheses, and dffe pre area is equal to 1, and dffe brackets furnishing ordeal is equal to 2 as type int. Basically what this line of code does is basically creates like a binary indicator as like such as like ones or zeros for like the premier properties, such as like where they like need to have all the 3 conditions listed here, where if it has like air conditioning and is located in a preference area, and it basically is furnished is equal to 2, and then as type int basically converts the boolean result to an integer, whether it be like ones or 0. So yeah. Then we move on to dffe price preferential area equals to DFFE area times DFFE preferential areas. Basically, what this does is basically it multiplies the house area by like the preferential area indicator, like whether that's like 1 or 0. When it's like in a preferential area, the preferential area is equal to 1, which is equal to the area, or otherwise this becomes 0. Basically, this captures like how the value of like the area differentiates in like a preferential versus a non-preferential location. Next, we move on to DFFE stories areas is equal to DFFE stories times DFFE area. Basically, what this line of code does is basically it multiplies the number of stories times by the total area. This captures like how the value of like a multi-story house might differ from like a single story house of like basically the same area. Then we move on to DFFE it's brackets F brackets area per bedroom, total room, premium property, area preference, and story area brackets dot head dot parentheses. Basically, this shows us like the first 5 rows of the newly created interaction features. Next, we move on to data processing and normalization. So I did from sklearn preprocessing, I imported standard scalar, min-max scalar, and robust scalar. And then from sklearn model selection, I imported train test split. So I did x is equal to dffe dot drop parentheses brackets price furnishing status brackets access is equal to 1. Basically, what this does is it creates like the feature matrix X by basically removing the price target, which is the target variable that I wanted to predict, and the furnishing status from like the original column. Then we move on to Y is equal to DFFE brackets price. Basically, this creates like the target vector Y containing like the house prices to be predicted. Then I basically afterwards I printed all the missing values in the features. Over here we can tell none of them have like any missing values in the features, so which is good. Next, I moved on to splitting the data into training and testing data. Basically, x train, x test, y train, y test is equal to train test split. What basically does is it basically splits the data into the training and testing tests, as 80% of the data goes into training and 20% goes into testing. Afterwards, I printed like the shape of the training data and the shape of the testing data. So training set size is equal to 436 rows and then 20 columns. Testing set size is equal to 109 rows and 20 columns. Next, we move on to comparing different normalization techniques. So numeric columns is equal to brackets area bathroom till up to areas storage area brackets. Well, basically what this does, it creates like a list of like all the numerical features that need to be like normalized. Then standard scalar is equal to standard scale till x standard as brackets numerical columns equal to standard scalar dot transform x test brackets numerical columns. Well, basically this block of code does it basically creates like a standard scalar object, and it basically makes the copies of like the testing and the training data to preserve like the originals, and then it basically transforms the numerical features by basically standardizing them, which is by basically minusing the mean and dividing it by the standard deviation. And this is basically important for like algorithms that are sensitive to like feature scales, so such as like linear regression. Then we move on to min-max scaling. So min-max scalar is equal to min-max scalar till x test min-max brackets numerical columns is equal to min-max scalar dot transform x text brackets numerical columns brackets parentheses. Well, basically what this block of code does, it basically creates a min-max scalar object and then makes copies of like the train test data, and then basically scales the feature to like a fixed range, which is like around from basically from 0 to 1 by subtracting like the minimum and dividing it by the range. Next, we move on to robust scalars equal to robust scalar, all the way up to then x test robust is equal to the numerical columns equal to robust scalar that transform x test brackets numerical columns. What this basically does is basically as usual, it creates a robust scalar object, basically makes the copies of the train test data and scales them based on like such as medium and interquartile range instead of using like mean and standard deviation. Basically, robust scalar is less likely to be influenced by like outliers as compared to like standard scalar. So yeah. Then we move on to PLT, fig compare, fig size 15 to 5, all the way up to PLT.show. Basically, what this blocks of code it basically does, it compares the distribution after just scaling for like the area feature. Basically, it plots like the area for like features for like it creates a histogram for like the area for like the original area, the standard scalar, the min max scalar, and then the robust scalar. So in the original data, the data is right skewed, as majority of the houses are like between like 25,000 to 15,000 area, and then there are fewer houses beyond like the 10,000 range over here, which is typical for like housing data, as like there are more like average size houses as compared to like a more mansion type of houses. Then the standard scalar graph over here, plot over here. Basically, the shape remains unchanged. It's still like right skewed. However, the scale is transformed now. The x-axis basically ranges from like basically -1 to like 4. The mean is standard at 0, and each of like the unit represents like the one standard deviation. Next, we move on to min max scalar. So all the values are now compressed from 0 to 1. The shape is still as before, which is right skewed. Smaller houses are now at 0, as the larger houses with area are now 1. Then we move on to robust scalar. So now the x-axis basically is now from -1, 4. It's similar to like the standard scalar over here, but instead it uses like medium and quartiles instead of using basically using mean and standard deviation.